Hello and welcome to Tech Dicted. I am Doreen Chamweno, and for this time we're going to be looking at number systems. So number systems include binary, octal, decimal, hexadecimal. Now we're used to the decimal system. That's what we use in our day-to-day basis. That's 0 to 9 and represent it in different ways for us to do analysis, to do statistics, to find out sensors, anything you want to find out. That's what we commonly use. Computers use binary systems. And so between binary and decimal, we need octal and hexadecimal to represent binary forms, as you will see throughout this videos, that in a binary form, these words are too long. Bits, bytes, they're too long. But when we start minimizing how the size using octal and hexadecimal, it becomes more useful in other different cases, and we will talk about that later. So binary systems only use two values. Okay, we only have the base 2. It's called the base 2, and we only use 0 and 1. So in a binary system, you don't go past 1. In an octal system, it's base 8, and you use 0 to 7. That means you don't go past 7. In the octal, in the decimal, which we're used to, it's 0 to 9. And then after 9, you now start adding them to each other. Okay, so we start again 10, 11. So you're starting to add 0, 1, 2. Okay, the first number remains the same. Then you're adding the 0 to 9 again. Then increment the first number to 2, add 0 to 9. That's exactly what we're doing with the binary, and it's also the same for this 2. So you just use the knowledge you have for this while we're doing this sessions, and it will be very helpful while you're calculating all the rest. The hexadecimal, now we're using 0 to 9, and then we're also using A to F, because hexadecimal is base 16, and so 0 to 9, those are only 10. Then we add alphabetical letters, capital A to capital F. Okay, and that's it for number systems. This is what we're going to be covering in the upcoming videos. Another concept that is going to be important as we proceed onwards is going to be the place values. As you remember in your primary school or whatever you call it at your place, we use place values, okay, to represent numbers. So that when I say 1592, I know it's 1592. How did we do that? We know this is the ones, if you remember, ones, tens, hundreds, thousands, and each of them is multiplied by 10 power something. Okay, so for the first case, for example, here we'll have times, okay, 10 power 0 times 10 power 1, and you proceed with that, times 10 power 2 times 10 power 3. And that's exactly the same thing we will be doing for both octal, binary, and decimal numbers. So when you multiply this way, you get 10 power 0 is 1, 10 power 1 is 10, 10 power 2 is 100, 10 power 3 is 1000. Okay, and now we get to find that when we add 1 times 1000, 5 times 5 times 100, 9 times 10, and 2 times 1, we get this value. And then we call it 1592. Okay, so this is the exact same concept I want you to keep in mind while we look at binary, octal, and actually even decimal and hexadecimal numbers. Number systems. Yeah, so that's it for now. Let's get started on binary number systems.